Hello, this is an example problem that will help you with your Week 10 MyStatsLab homework problem 4. And in this problem we have a food company that is concerned about the recent criticism of the sugar content of their children's cereal. So they want to take some samples and try to prove that their children's cereal doesn't have any more sugar than their adult cereals. So from this we can draw our null and alternative hypothesis. So our null hypothesis will be that there is no mean difference between the children's cereal and the adult cereal. So that means our alternative hypothesis will be that the mean amount of sugar in a children's cereal minus the mean amount of sugar in our adult cereal is not equal to 0, or that they are significantly different. So we'd like to conduct a 2-sample t-test, but let's make sure all our conditions are met. It is reasonable to assume that the sample of cereals are representative of all children's and adult cereals in regards to sugar content. We can also see by our sample sizes the amount here. We have 20 samples in our children's cereal, 30 in our adult cereal. So they are large enough to assume that the samples are going to be nearly normally distributed. And our third condition is that they be independent, and we can assume that the sugar content in children's cereal has nothing to do or is unrelated to the amount in adult cereal. So since we have met those three conditions, we can conduct a 2-sample t-test. Well, let's go back and look at this box I have up here that's showing the results from our Excel analysis. So the way I got this information here, we go to Data and click on Data Analysis, and you will see here we have a t-test, 2-sample assuming unequal variances. This is what we're going to use. So from here we can click on OK, and you'll see it asks you to input variable range 1, so I can click children's cereal all the way down, get this data for that cell. Click on the next, and we can put our variable for range 2 here. It also asks us the hypothesized mean difference, and we're saying that there is no difference, so we'll put 0 here. Check our labels since I highlighted those, and I can click OK. I'm going to cancel this, but you click OK, and this is the results that you get. So we have the mean of both samples, the variance, the number of observations, degrees of freedom, our t-stat, p-stat for one tail, t-critical for one tail, p for two tail, and t-critical for two tail. So this is a lot of information that we will need, because our next step is to compute a 95% confidence interval for the positive difference in means. So for this, we're going to need to know the standard error of the difference between the sample means and the critical t. Okay, there are two methods we can use to come up with this. The first method here, we're going to go ahead and find the standard deviation of both samples. I'll click on my formula here, and it is simply the square root of F13. Well, what is F13? F13 is our variance. So our standard deviation is merely the square root of our variance. So we can do that for both adult and children's cereal. Our standard deviation for children's cereal here, standard deviation for our adult cereal here. Now we need to calculate the standard error, and for this we can use the formula at the bottom of page 373. I'll click on my cell here, and you'll see that the standard error is the square root of standard deviation of children's cereal squared divided by n, which is right here, 20, plus the standard deviation of our adult cereal squared, as you see here, divided by that sample size, which is 30. We can do this and we come up with 2.204. Now, we can also come up with that same answer right here. As we noted earlier, we have the variance for each cereal sample size already listed in our data results at the top. Well, if you can recall from your reading and working with statistics, that we know the variance is the standard deviation squared. And we already have the variance above, so we can eliminate some of the steps that we did here. And you see here I take the square root of F13, which is the variance, divided by F14, which is the n for this sample, or 20, plus G13, the variance of our adult cereal here, divided by the 30 there. Now that just sort of makes our formula a little bit simpler, and we get the exact same answer, 2.204, either way. So you can do that either way. But we know the variance and the standard deviation are related, and related by the square or the square root, depending on which one you have. So you can do either one of those methods to come up with your standard area. Now we also need to find the critical t. Well, we already have it right here at the bottom of our data results. Since this is a two-tailed test, and it is two-tailed because we are not equal to 0, which means we can be above or below. So we can use the t critical for our two-tail, or 2.020, which I merely copied and pasted here. Now that we have everything we need, we can go ahead and calculate our confidence interval. So our upper limit, and you see our formula, F12 minus G12, which is the difference between the two means, which we already have calculated here, and minus, and then we're going to take our standard error and our t critical t and multiply those together and subtract it from that difference, and we get our upper limit of 31.16. Same thing for the lower limit, only we're adding that the critical t and the standard error multiplied together here, and we get our upper limit. So not too tough there. But once we have these two, we can say that our 95% confidence interval of the sample means is approximately 31.16 to 40.06, and I think the measurements were in grams. So now we move to our last part, part D, and it asks, is there a significant difference in the mean sugar content? So our answer would be the 95% confidence interval does not include 0 in here, so there's no difference value. So for our two-sided hypothesis, we can conclude the mean sugar content is significantly different at the 5% level of significance. So there you have it. A good example to go along with your problem 4 in MyStatsLab for week 10. Hope this helps.